Hello, Algebra 1, and this is the second part of Lesson 7, 1 and 2 videos. Remember, label and date all your work and complete your work in your notebook. So first of all, we have our warm-up, our grit problems. So pause the video here and complete in your notebook. So let's go over warm-up problems 1 and 2. We're multiplying these factors together. And if you recall from chapter 6, if we have a binomial times a binomial, we're going to use the distributive property twice here, the FOIL method, and we're going to get our product. So here goes. We are going to first distribute the x. So we've got first sides, x times a is ax. X times b is bx. And yes, I'm just trying to be careful here to put these in alphabetical order just because it's good algebra manners to do so. Then we've got the second term to be distributed. So 3 times a will be the inside terms and 3 times b will be the outside terms. So 3 times a is 3a, 3 times b is plus 3b. Now, we've created a polynomial that has 1, 2, 3, 4 terms. And none of these terms are like terms. So that's our final product. Not every single time is something going to be able to be combined, and this is one of those times. So there is warm-up number 1. Let's do warm-up number 2. Warm-up number 2 is x minus 4 times 2x plus 5. We'll do this one a little bit more quickly. First sides, 2x squared. Remember, this is x to the first times x to the first. Add the exponents when we're multiplying and the bases are the same. Outsides, x times 5 plus 5x. Negative 4 times 2x, negative 8x, and then negative 4 times positive 5, negative 20. Now in this case, we do have like terms in the middle, and we will combine like terms. So a final product, 2x squared minus 3x minus 20. So that's warm-up problem 1 and 2. Here's number 3. This time we're going to do what we did in the last video. We're going to factor out the greatest common factor. Remember, we're always going to start by looking at the coefficients first. 3, 15, and 6 are all divisible by 3. So we're going to come through and we're going to divide everything by 3. I'll quickly write it again. So dividing everything by 3 using a factor ladder here. 3 divided by 3 is 1. 1s to the 4th. Negative 15 divided by 3, negative 5s to the 3rd. 6 divided by 3, plus 2s squared. All right, so we took care of the coefficients. Now we're going to work on the variable s. And every single term has at least 2 powers of s. So that's what we're going to take out. So s squared is coming out. We're about to divide, and when we divide, we subtract the exponents of the like bases. So s to the 4th divided by s squared, we have s squared. 4 minus 2 is 2, and there's a 1 up front. Negative 5 s to the 3rd divided by s squared leaves s to the 1st. 3 minus 2 is 1. 2s squared divided by s squared is just 2. 2 minus 2 leaves 0 powers of s. Remember, our GCF is over here on the left. So when we factor out the greatest common factor, 3s squared, the GCF comes first. And then whatever we have left right down here, 1, 2, 3, this is a trinomial, we'll put it in the second set of parentheses. And you can write that one or don't write that one. It doesn't matter there. They mean exactly the same thing. Number 4 in our warm-up, if you notice, our GCF this time is not a monomial factor, but it is a binomial factor. So y plus 4 is the GCF that we are going to factor out. So let's rewrite the problem. 10x y plus 4 minus 7 times y plus 4. And y plus 4, and yes, I'm going to keep it snugly and warm in those parentheses because I'm not going to break it apart. It is one factor, y plus 4. So 10x times y plus 4. If we divide away the y plus 4, all we're left with is 10x. And then here, if we divide away the y plus 4, all we're left with is a minus 7. So if y plus 4 is our greatest common factor, and we bring it to the front, what's left? 10x minus 7. So these are my two prime factors. That's what we're doing here, breaking down to prime factors every single time. So in the continuation of this lesson, we're still talking about factoring. And remember, factors are what we get when we divide. So today we're going to learn how to group terms of a polynomial. And yes, we're going to be using the associative property. Remember, the associative property has everything to do with parentheses, where we're going to be grouping things together in order to find a GCF. So please write down this next sentence. We use grouping when there are 4 or more. 4 or more. So be certain to write this down. We use grouping when there are 4 or more. Okay, so what does that mean? Well, let's take a look at the next problem. So let's consider this polynomial and look at this question. How many terms are there? 1, 2, 3, 4. There are 4 terms. If we have 4 or more terms, we're going to need to group some terms together in order for us to factor. So we're going to use grouping here. And the first thing we're going to do is we are going to split this polynomial right down the middle. And we're going to group together the first 2 terms and the last 2 terms. Now pay attention in that sign that's in front of that term stays with that sign or with that term. So that is positive 3x. Keep the sign with it, most especially if it's negative. Pay attention to that. So once again, how many terms? 4. So we're going to group the first 2 terms and group the second 2 terms. So if we just look at the first 2 terms, do the first 2 terms have a greatest common factor? Yes. The 2 and the 8 are both divisible by 2, and the x to the third and the x squared are both divisible by x squared. So the GCF of the first 2 terms, just what we did in the warm-up, just what we did in the last lesson, is 2x squared. We're just going to start skipping the factor letter part and just immediately take out the GCF. So this is the GCF. So what's left? 2 divided by 2 is 1. X to the third divided by x squared is x. 8 divided by 2 is 4. X squared divided by x squared, 2 minus 2 is 0. So we just took out the GCF and we have the remaining factor right beside it. So I'll slide my card over and let's look at the second 2 terms in this polynomial. How many terms were there? 4. So we grouped them into 2 groups of 2. So now we've got 3x plus 12, positive 3x plus 12. So what's the GCF of 3 and 12? A positive 3. And this term has an x, but this one does not. Therefore, 3 is the GCF of these 2 terms. That's it. So what's left? 3x divided by 3 is x. 12 divided by 3 is positive 4. So we took out the GCF of the first 2 terms, then we took out the GCF of the second 2 terms. And now we have a new GCF. And this is what we just saw in our warm-up. Now we have a new GCF for the entire problem. So now we're not just considering the first half or the second half, we're looking at the whole thing from a bird's eye view. And now we have a GCF of x plus 4, which we will then bring to the front and then divide both terms by x plus 4. So if we divide this by x plus 4, we're left with 2x squared. If we divide this by x plus 4, we're left with 3. So now we have factored completely by grouping. Let's do it again. 1, 2, 3, 4. How many terms? 4. We're going to split them down the middle, and we're going to take out the greatest common factor in the first 2 terms. A 4 and a 3 have nothing in common, but n cubed and n squared both have at least 2 powers of n. So 4n cubed divided by n squared is 4n. 3n squared divided by n squared is 3. Slide the card over, do it again. Over here, 4 and 3 have nothing in common. This is n to the first, but this is no n. So if they don't appear to have any common factors, then the only common factor they could have is 1. And the magic here is the first set of parentheses and the second set of parentheses are the same. That makes it the GCF. Bring it to the front. And what's left over? N squared plus 1. That is factored completely by grouping. And just to show you that it's working, if we were to use the FOIL method here to multiply these back together, look at what we would get. 4n squared times n squared is 4n to the third. 4n times 1 plus 4n. 3 times n squared plus 3n squared. 3 times 1 plus 3. And if we were to put this in standard form, we would end up with what we started with. So this time, 10d squared minus 6d minus 35d plus 21. And I'm noting here that this minus sign is important. But first of all, how many terms? 4 terms. If there are 4 or more terms, you're going to split it down the middle. Remember to keep that sign with the number. Look at the first 2 terms. 10d squared minus 6d. What is the GCF? The GCF is 2d. They both are divisible by 2. They're both divisible by d to the first. Take out 2d. 10 divided by 2 is 5. D to the second divided by d to the first is d. Negative 6d divided by 2d is negative 3. Slide the card over. Remember what we saw in the first video? If you have a negative leading coefficient, then you need to take out a negative common factor. 35 and 21 are both divisible by negative 7. So negative 35d divided by negative 7 is 5d. 21 divided by negative 7 is negative 3. And just like magic, the GCF is 5d minus 3. Bring it to the front, and what's left over? 2d minus 7. One last example. Same thing again. How many terms? 1, 2, 3, 4. 4 terms. When there are 4 or more, split it down the middle. The greatest common factor of the first 2 terms is 3n squared. Let's take it out. 12 divided by 3 is 4. N to the third divided by n squared is n to the first. Negative 15n squared divided by 3n squared is negative 5. Slide the card over, do it again. Remember when we have a negative up front, bring out a negative greatest common factor. Negative 8 and 10 are both divisible by negative 2. This term has an n, this one does not, so negative 2 is our GCF. What is left? Negative 8n divided by negative 2 is positive 4n. Positive 10 divided by negative 2 is negative 5. Once again, the binomial 4n minus 5 is our greatest common factor. Bring it to the front. What's left? 3n squared minus 2. Those are our factors. Summing everything up, the last 2 videos, cover factoring out the GCF and grouping. Remember, we always look for a greatest common factor, no matter what, first. Also remember, we utilize grouping if there are 4 or more terms. You can find your homework assignment on our Google site on the topics page of My CCA.